as with any network, I always like to start with the applications, right? That's the whole reason we even have this infrastructure, is to deliver applications to our end users. So as you'll see, I'll have this 4-site enterprise. They have, kind of HQ site and 3 branches. Got a little house chilling down there. We'll touch on that in a minute. So typically, we see most enterprises having their applications either at headquarters or a colo. So at this one, we're going to say these guys have it at their headquarters. So again, what kind of applications do we have? Traditionally, we're always going to have our email, right? Kind of lifeblood of communications out to our clients and partners. Beyond that, typically, see voice. Unless you're running on an antique digital system, pretty much everybody's kind of made that migration in a VoIP environment at this point. Then generally we're always going to see a CRM or ERP system. And then, depending on the business, oftentimes, see a POS for those kind of more retail-focused clients. So we have all our applications at headquarters, and how do our branches connect to those applications? The traditional way to do that or achieve that was through some kind of private connection. As Kyle, kind of mentioned, typically see the MPLS, EVPL, VPLS, other acronyms that carriers try to come up with to tell you that they have a unique, private connection product to sell you. So if we're going ahead and just go with MPLS, it's kind of one of the more ubiquitous. And then typically we're going to have some kind of branch router that's going to sit out here. And everybody's going to have a connection into the MPLS cloud. Depending where you are and what time or what point in time you went with this private connection, not rare at all to see these T1s of that blazing fast, 1.5 megabit. Still not sure why we're using 70-year-old technology, but it's still widely deployed. But you might have some branches and a newer footprint or newer branch, so. You might be lucky enough to get, 10 meg fiber or something like that. So now we have connectivity back to our headquarters. Of course, we have on-prem applications, but our end users still need to be able to access the internet. So typically, we're going to, see a firewall up here, connection down to the router, probably some switches in there, and the internet. So again, pretty simple. This is how we've been operating for last decade plus. We have our tried and true MPLS network. We chose that for a few reasons, right? It did give us QoS, so that ability to tag, specifically our voice traffic is what we're most concerned about, with a priority, say, your EF or expedited forwarding queue. We also get guaranteed bandwidth, and we get SLAs. SLAs are, of course, I was thinking kind of a joke. What I have to do, I have to go open a ticket, and how long the ticket's open reflects how many credits I get. Not uncommon to see $8 on my $500 circuit, but that's a side rant I'll save for another day. So, but again, now we're looking at this, and wow, there's a T1 branch, and wow, I just have a single circuit back to my headquarters. So I do have a point of sale. Say I'm running credit cards. I do have that retail branch. I just have one circuit out. What happens if that goes down? Can I serve my clients? More importantly, can I sell them things and take their money? Right? That's why we're all in business. Of course, the answer would be no. So due to the bandwidth restrictions or restraints and that single point of failure, very common to see internet also deployed. When I say internet, kind of can't see me doing air quotes. Oftentimes that's used as just another backhaul method, right? So many people come out here and deploy our firewalls. And to maintain that single point of failure, or that single, well, it is, but that single security appliance, so I don't have to go through and configure, many firewalls on this. I'm looking at 3 remote firewalls if I want to do security policy on those. But obviously, you start scaling at 10 branches, 50 branches, 100 branches, that becomes unsustainable. So, I oftentimes see most people, creating VPNs. So I kind of maintain my same backhaul environment. I maintain, that single source of security policy, auditing, logging, those UTM features, that type of thing. And then I set up some kind of lame, failover. I call it lame because, computers or routers and firewalls are pretty lame about knowing when there is a failure, right? What you're sending and ping every 5 minutes or so, or every 5 seconds or so, and you wait for, 5 or 10 of them to fail, and then you deem a circuit has failed. And when we do that kind of backup, it's disruptive, right? If that VPN tunnel goes down, then I do fail over the MPLS. All of a sudden, I'm back on that amazingly fast 1.5 megabit of bandwidth, and users hate themselves, and you generally. And again, it's disruptive, right? So if I did have a wake call, if I was in the middle of a point of sale transaction, if I was running a credit card, any of those sensitive things, that drops, restart. So, and another problem we start facing is if you have a cloud focused migration plan, which we generally see everybody do, that just does not play well in this environment, right? I mean, I don't know how much you guys love administrating an Exchange server. I can't tell you how many nights I stayed up troubleshooting that thing. A lot of people are moving Office 365, right? Make email somebody else's problem. Same with voice. As much as I love, having all those PRIs and doing all this, ATAs and POTS and all that type of thing. See a lot of that moving up, right? Got all your UCaaS or hosted voice. CRM, Salesforce, big player out there, moving up. Point of sale. Again, a lot of people just don't want all of that in their data center, right? If I'm going to do Office 365, there's a really good chance, Microsoft's able to do HA, DR, and all that a lot better than you. It's a good chance that, you have your Ring Central, your Bytes, your big UCaaS players. They're going to be able to make that environment much more redundant and have a much better uptime than you are. So as we see a lot of our clients in that migration, this whole backhaul scenario becomes even more, just traditional looking, right? So if I say I do have hosted voice, across the CPM, let's just say maybe I incurred about 30 milliseconds latency VPN in back. So now I'm back at my headquarters, got my hairpin in that bandwidth, and then I reach out to the provider, just call another 30 milliseconds. Obviously, voice is generally going to be good inside 100, but you can see where, we start fudging these numbers a little bit. All of a sudden, we are starting at a higher latency, right? So, and we're double dipping bandwidth at headquarters. All of a sudden, I have to have a larger pipe there because, everything's coming in and then leaving on that same connection. So as you can see, as we do start having that migration, it just doesn't make sense. So again, we find our clients have this situation all the time. For a legacy, slow, expensive MPLS, augmented by internet with some kind of sloppy failover, if any. Sometimes that is manual. And then again, everything's just backhauling at HQ and just does not play into any type of hosted internet service at all. So what does SD-WAN bring to the game? So as you see, we've started our cloud transition, and we're thinking about, hey, how do we get off this MPLS? What does that look like? So again, SD-WAN, Kyle gave a great overview. Really what we think about SD-WAN is, in that traditional environment, I kind of call it a layer 3 network, right? Or it's just a next hop network. I'm the subnet. How do I get to the next subnet? How do I get out? How do I get out? Maybe I do have two paths. I'm going to prefer one over the other in some kind of static or dynamic fashion, depending if you're using dynamic routing or not. If that path all of a sudden goes away, I'm going to fail over the other path. But none of that forwarding on that network across the MPLS or across those VPN tunnels took into account the health of the circuit. Nor did it take into account the applications, right? Maybe you put in some policy-based routing in a static fashion that says, oh, if you're hitting my voice server, I want you to go this way. But yeah, nothing in that path was aware that that's voice. It doesn't know, what application you're using at that more, kind of layer 7 level. So, and then again, the MPLS, that QoS, we often see a lot of our security conscious customers VPNing across the MPLS. So it goes away that whole, QoS ability, right? Once you encapsulate, say, voice inside of a VPN connection across the MPLS, you lose that. Again, the SLA credits, we're starting to see internet circuits, at least as far as just pure uptime, being on par, right? A lot of times it's going to be the same medium. It's going to be the same fiber. It's going to be, selling the same medium last mile to you. So what does this look like? When displacing MPLS, again, a lot of times we'll walk into a client, they already have an internet circuit. So generally, source a second internet circuit, and we throw, actually, let me go black, an SD-WAN appliance. So that SD-WAN appliance is going to displace, that current MPLS router. So thinking that as, your routing point. So let's say we do still have a few applications on-prem, right? We're never going to be quite lucky enough, or it's probably some time until everything goes up to the cloud. So to maintain that same on-prem, what does that look like? So like I said, generally like to see 2 internet circuits terminated into an SD-WAN appliance, and using the internet as a backhaul. So, or as a connection medium, I should say. So let's say our CRM is still living down here. And also, for example, let's just say we still have our voice living down there too. So when we talk about multipathing, that is, on either side, I like to think of an A and a B path, right? So headquarters have an A and a B circuit. For those circuits, we always recommend last mile diversity and carrier and medium. What I mean by that is I want to see a fiber and a coax, or a coax and a DSL, or a fiber and a WISP, or something like that. The reason for that is, carrier diversity, right? So I don't want a Comcast, coax, and a fiber due to, if there's an issue in their backbone, good chance of that traffic will be commingled at some point. Also, there's an issue with the peering relationship, right? Comcast is pretty famous for having piston matches with Cogent all the time. We don't want both of our paths to be affected by something like that. Plus, there's always that notorious fiber-seeking backhoe. I don't know why. It always finds the fiber. So, if I deal with a fiber and a coax, I do have a catastrophic event where that fiber gets taken out, that coax circuit's going to stay up. So, multipathing between those, actually, let me write fiber and the coax. So, at a branch location, say I have a coax and a DSL. So as traffic passes that SD-WAN box, again, we're looking at that traffic at layer 7. So what does that mean? It means I know it's a voice. I know it's, Office 365. I know it's, Salesforce, or I know it's Twitter or Facebook or something like that, right? So now I can start making forwarding decisions on that. So as far as the multipathing, getting on my coax, I have a voice call there. And that voice call is going back to HQ since I still have my voice on-prem. So it's going to evaluate on my branch side, I have my A and B, and on my headquarters side, I have my A and a B. So really I have 4 paths to choose from, right? You can go A to A to B, B to A, B to B. So these SD-WAN boxes are talking to each other several times a second, oftentimes it's 10 plus depending on the product. And they're doing health checks across all 4 of those paths to measure the latency, jitter, packet loss, and available bandwidth. So again, I have my voice call coming in, going to HQ. I'm concerned about which path at this second in time, sub-second in time even, is the best path for this voice. What does the voice care about? Low latency, right? And low jitter and 0 packet loss. Well, it's probably, it just doesn't care about bandwidth, right? You're probably using just a G711 codec, roughly 100K. Don't care about bandwidth. I just, whatever path is really going to have the least of the latency, jitter, and packet loss. So let's say in this case, that best path happens to be the coax on the one side and the fiber on the other side. So my little blue line. Let's say there's some degradation of the circuit, right? Degradation can take many, many forms. Generally, I don't see a whole circuit failing, but if you have like a coaxial shared medium, say kids come home from school, they start Netflix, watching all the cat videos on YouTube, playing on battlegrounds, that type of thing. There's a good chance that latency is going to go up and bandwidth is going to go down. It's just kind of the nature of coax. Well, if it does happen, and it could degrade enough to where that latency starts affecting possible voice quality, these SD-WAN appliances generally create GRE or IP suck tunnels between them, so that encapsulates the traffic across all 4 paths. That gives me the ability to real-time move that call that was on that coax and fiber over that DSL and fiber. That's super powerful, right? I mean, in the past, if I had firewalls that were doing IP suck tunnels between them, I had multiple paths, that would have been disruptive, right? I would not have been able to real-time move that voice traffic or any traffic for that count between them. Another thing I can do is sub-second failover between those. So that fiber seeking back to, once again, rears its ugly head, took out that fiber at headquarters. I can real-time move that voice call over to that coax circuit at headquarters. So again, super powerful in SD-WAN technology. Another thing all the SD-WAN products have in common is meshing VPN. That was another kind of traditional problem. One reason we loved MPLS was just that meshing was built in, taken care of by the carrier. So I went and got a bunch of internet circuits. I did a bunch of IP tech tunnels. It's an extremely manual process, right? So in generalities, all these products have that meshing VPN built in. Used to deploy another SD-WAN appliance. It's aware of all the other SD-WAN appliances, what subnets are behind them, and can bring up tunnels real time. So at that point, deploying branches becomes much, much easier. You just throw a new appliance out there. All right, so I'll delete that. So again, that was just on-prem, right? I'm using my voice example there. So let's say that I do deploy Ring Central. So I no longer have my voice on-prem, now my voice in the cloud or a hosted provider. So traditionally, I'd be backhauling everything for my single security appliance, but now my voice is hosted. I don't want to backhaul everything due to incurring that extra piece or that extra latency. So what we can do with SD-WAN is now that we're making those forwarding decisions at layer 7, I no longer just have the next hop out of the network. I can say, hey, that Ring Central, it makes no sense to backhaul that. I just want to egress that straight up to the cloud, straight out of those internet connections. So what we can do is, depending on the provider, SD-WAN company, most of them are going to operate, some kind of cloud gateway or a POP. So it's called POP just to be agnostic. So point of presence. One of the main SD-WAN partners that we use have about 80 POPs globally, sitting next to pretty much every application. So what that looks like for them is they just went to Amazon, Azure, Google Cloud Compute, Equinix, anywhere they could spin up some kind of VPN or VM or VPS or something like that. And they operate these gateways, which allow that same exact multipathing except up to them. And there's going to be one probably dedicated to Office 365, Ring Central, that type of thing. So I have my branch over here where now all of a sudden I multipath up to that POP. So again, I kind of have an A/B side ability to choose the best path. And then they're going to dump me straight out onto my SaaS app, which more or less creates a QoS overlay. Again, I'm not setting the IP header QoS like I did on my MPLS. I'm not saying, hey, you're EF, you're going to egress that on the internet. Nobody's going to care. Well, all of a sudden, if I can give these SD-WAN appliances 2, 3, even 4 paths, all of a sudden, with the addition of all those extra paths, that gives me the ability to make these routing decisions for the best type of traffic. Plus, having that POP, you kind of have to bookend things, if you will. I mean, kind of need a place to do that health checking and do that encapsulation of the tunnels, so which enables me for that sub-second failover. To where if I do lose a circuit because I'm encapsulated at the POP, I switch to other tunnel and then again dump that traffic kind of out on the internet. Of course, with all this cloud migration, security becomes a problem, right? I mentioned that we love that MPLS or that backhaul mentality where I can maintain a single security appliance and do all my policy there. Well, all of a sudden, now I'm trying to kind of split things out. Do I egress everything up to the POPs? Do I backhaul some? The beauty about SD-WAN is, again, I'm making those routing decisions at layer 7, really frees me up for that capability to do whatever I want. We have many clients that kind of operate in a whitelist scenario. So they do have an Office 365. They do have some kind of hosted voice. They do have, collaboration tools. Why are you going to backhaul WebEx, right? Why are you going to backhaul, just traffic that is going to be pretty much useless to run through a UTM or a security appliance? So again, we do still have the flexibility of having our tried and true UTM. You paid a lot of money for that Palo Alto or other security appliance, and you still want to use it, right? So we'd have the ability to say, hey, again, anything that doesn't make sense to backhaul, let's natively egress. Let's have those cloud POPs, which gives me that kind of QoS overlay and sub-second failover, so I don't have disruption if there's any degradation or catastrophic failure. And everything else, I want to backhaul back to my headquarters and out my security appliance. So again, we just have a lot more freedom than we had in those traditional environments where I'm doing everything kind of at layer 3, next hop, next hop, next hop. So with that, let's have story time. So let's say my CEO is sitting out at a branch, right? Say headquarters far away. He lives in his house, a few minute drive to work. He's sitting in his office. So on the phone, again, you had a hosted voice where you migrated. He's on a phone call with super important investors, right? And that fiber seeking backhoe comes up again and takes out that circuit. What just happened to that phone call? Nothing. Very uneventful. Again, traditional environment where I did have the MPLS and I had a VPN backhaul, or I had multiple internet connections, or I'm doing a lame load balancing out those internet connections because my firewall doesn't know about the health of those. Pretty catastrophic failure at that point. CEO is probably mad. Or let's make it more personal. What about your paycheck? Say the accounting lady is submitting payroll up to ADP. Circuit goes down. She misses the deadline. Or conference call. Yeah, you can see there are definitely times to where having that internet connectivity and non-disruptive failover become really important. All right, so let's talk about security. As Cal kind of mentioned on, perimeter's dead. You can especially see that here, right? Where half my applications aren't even in my data center anymore. It used to be that, my end users would be behind the protective, cover of my UTM, or they'd be remote and then they had access on-prem applications, they'd VPN in. I just kind of had this, demarcation point of where I could apply policy of things coming in and leaving my network. But now with half my applications gone, what does that look like? One thing that we see many of our clients do is go with some kind of cloud firewall. What is a cloud firewall? It's pretty self-explanatory. It is you creating some type of tunnel to somebody else and letting them deal with the security. So this plays really well with SD-WAN. Again, I can multipath up to the POP, hit the cloud firewall, then hit my apps. I can have the ability, again, just like with that backhaul, to not even send those apps up to the cloud firewall. Really depends. The really nice thing, though, is if you have someone roam off the network, say my sales guy or CEO's at home, generally all these cloud firewalls are going to have an agent. The agent then can enforce policy where they are. Same on phones, right? We can have MDM, that type of thing, enforce all this policy. Now we're to a point where I don't care about my UTM at headquarters. I don't have to backhaul any traffic, right? That generally lets me reduce my internet pipe at headquarters. Oftentimes you need it 30, 40, 50, percent larger than it needs to be, purely because you're doing all that hairpinning of backhauling traffic at headquarters and having it egress to the new UTM. So another nice thing is just we'd have that single management plane. And again, we're going to get back to the cloud firewall vendors going to be able to do HADR and have just a more significant uptime than you're going to be able to. Again, unless you have HA firewalls, AB power, redundant air conditioners, redundant UPS, redundant fiber loops. Again, getting all that stuff out of HQ just starts to make more sense. All right, lastly, so I keep talking about, setting policy and setting routing and that type of thing. Generally, all the SD-WAN platforms come with some kind of central orchestration or central dashboard. Virtually none of them allow you to, sit there and artisanally administrate them like you used to. As Kyle kind of touched on, on your old network, I have 10 sites, I have 10 firewalls or routers or switches or whatever it looks like, and I'm managing them all completely independently. That's pretty much gone by the wayside with this new evolution of SD-WAN. Generally, you log into a portal and you set policy across all appliances. Another thing you also get is analytics, right? They're making all these routing decisions and all these health checks, again, based on layer 7. And all of that analytics generally is going to roll up into that dashboard. It gives, most administrators a view that they've never seen before. Unless you, have routers are capable of doing some kind of net flow or IPFix flow, and you have some kind of collector, have some really nice, shiny, expensive product like SolarWinds. That's just information you've never had before. And that stuff just comes along with generally all the SD-WAN products. All right, well, that ends my demonstration.